Okay, welcome. In this video, we are going to take a look at the following example. We're going to find the solution set to the following homogeneous system. x1 plus 3x2 plus 7x3 equals 0. x2 plus 3x3 equals 0. And the third equation is minus 2x1 minus 4x2 minus 8x3 is equal to 0. So here we have a homogeneous system because on the right side of all three equations, the constant is 0. So if I want to solve this system of linear equations, then we can go ahead and set up the augmented matrix. So I've got my coefficients for x1, coefficients for x2, and x3 as the first three columns in this matrix, and then I add the 0 vector, the 0 column over here, since we have a homogeneous system. And then we do the same thing, whether the system is homogeneous or non-homogeneous. That is, we're going to do elementary row operations and do row reduction on this augmented matrix and put it into reduced row echelon form. So the first step in this process would be identify a pivot in the top row and then get zeros beneath that pivot. So we have a 0 here. In order to make this one 0, we're going to replace row 3 with 2 times row 1 plus row 3. And after doing that operation, row 3 now becomes 0, 2, 6, 0. And now we move down to the next column. And this submatrix in here, we need to do row operations on this. We have a pivot right here. So let's eliminate the entry below that pivot. Let's make this 0. So we multiply row 2 by minus 2, add it to row 3 to get a replacement. And you should see that that's going to cancel off both of these terms. So now I have an entire row of zeros. So this tells me that we have one pivot column here. We have a second pivot column here. And over here for the x3, there is no pivot in this column. So we should have an infinite number of solutions for this example because we have a free variable. But let's continue this process and put it into reduced row echelon form. In other words, we want to make sure that the entries above each pivot are also 0. So I can multiply row 2 by minus 3, add it to row 1 to get a replacement for row 1, and now row 1 would become 1, 0, minus 2, and 0. So we have a pivot in column 1. x1 is a basic variable. We have a pivot in column 2. x2 is a basic variable, but column 3 has no pivot. So from this, we can see that x3 is a free variable. And again, we're going to have an infinite number of solutions. And so we can represent this solution set in a number of different ways. So we solved for the variables x1, x2, and x3. So this vector of variables x, we have x1 is equal to 2x3, x2 is equal to minus 3x3, and x3 is free. And where these equations are coming from, again, would be from the matrix that we have over here, which says x1 minus 2, x3 is equal to 0. And so when we solve for x1, that minus 2 gets brought to the other side and becomes positive. And same idea for x2, that we would get a minus 3x3. And this is fine if we leave our solution in the form that is already here. We could pull out this scalar. So x3 is just a number. So this vector is equivalent to saying the scalar x3 times the vector 2 minus 3, 1, which we can then represent as x3 times v, where v is exactly this vector 2 minus 3, 1. So here's kind of a way of representing the solution as a vector. So this homogeneous system certainly has a trivial solution. If we set x3 equal to 0, then x equals 0 is a solution. But we also have a bunch of non-trivial solutions, an infinite number of non-trivial solutions. So for any value that I choose for x3, we can multiply it by the vector v, and that's going to give us a solution. So this solution set if we imagine that this is a problem taking place in R3, well then remember that when we do scalar product with a vector, when I multiply a vector by a scalar, what that does is it creates a vector which is parallel to v. It will change its magnitude. It might flip its direction, the exact opposite direction, but I'm going to get a vector which is parallel to v. So this solution set looks like a line through R3. Any vector in R3 which is parallel to v, well, that's going to be in my solution set.